Hello, and welcome to the channel. Today, we'll be covering series voltage dividers. If you're looking at your homework problem and it looks something like this, you may be dealing with series voltage dividers. If you're rushing to get that homework in, check out my channel where I cover this in under 60 seconds on YouTube Shorts. Now, let's jump in. Series voltage dividers are identified by one continuous line where components are placed in line with each other, in other words, in series with each other, without any branches. This shouldn't be confused with parallel voltage dividers, which look something like this. There's usually a small dot to indicate where the circuit branches off. This uses a whole different set of rules, which I will cover in another video. So let's take a look at the circuit we have and try to identify some important parts. On the left, we have a series of lines. This indicates a DC source. That means we have constant current and voltage in the circuit. Voltage is measured in volts and is like a force that pushes electrons through a conductive loop. In our case, this is the conducting loop. You can visualize this as a AA battery hooked up to a wire. On that wire, we have these little squiggly things. These are known as resistors. Resistors can be drawn like this, or in some cases, drawn like this. What resistors do is provide a controlled opposition to the flow of current. Resistors are measured in ohms, and current is the rate at which electrons flow past the point in an electrical circuit. For our purposes, we aren't too worried about the current until we get into a very important thing called Ohm's law, which describes the relationship between voltage, current, and resistance. Let's also take a look at these lines on the bottom. This is known as ground and can be used to avoid drawing a line between the end of a circuit and the negative of this DC source. These two grounds are the same as having a wire connected on these 2 points. When looking at any circuit, something called Kirchhoff's voltage law comes up. It states that the sum of all voltages around a single closed path is 0. In other words, the sum of all voltage drops equals the source voltage. A way to see it is that the source voltage will be completely consumed or used by the circuit. In the series circuit, the voltage or force of electricity has nowhere to go besides this resistor. If we have a 10 volt source here, we have a positive indicated by the long line and a negative indicated by the short line on the bottom. And if we have any resistance value here, doesn't really matter. This resistor, whatever it is, will be consuming the full 10 volts. If we have a 5 volt source, 5 volts, with any resistance value here, just like this resistor will be consuming the full 5 volts. So if we have a 7 ohm resistor here, the voltage across this will be 10 volts. If we have a 7 ohm resistor here, the resistance across this will be 5 volts. The same thing applies if we have more than one resistor. If we have that same 5 volt source and any 2 resistance values here, or any 3 resistance values here, the voltage will be completely consumed by these 2 resistors. Now, the question is, how much voltage will be used by each resistor? If these resistors are of equal value, then the voltage will be divided evenly between them. If we have two resistors, each with 4 ohms of resistance, and we have a 10-volt source, that 10-volt source will be divided into two parts, meaning that each resistor will have 5 volts across them. If these were each 10 ohms, or 20 ohms, or even 20,000 ohms, then the combined voltage across them would still be 10 volts, with 5 volts across each resistor. Now, before we move on, let's take a look at something. In a lot of cases, we will have very, very large resistance values. In order to reduce the amount of space used, we often use metric prefixes. The most commonly used metric prefix is kilo. Denoted as K. Just like with kilograms, where each kilogram is 1,000 of some base unit, if we have 20 kilo ohms, it's the same as 20,000 ohms. Let's try some more problems. If we have, instead of a 5-volt source, a 12-volt source, and 3 resistors, each of value 1.7 kilo ohms, or 17,000 ohms, then the voltage will be split evenly between the resistors. 12 divided by 3 is 4, so we have 4 volts across each resistor. We can indicate what resistor we're looking at by drawing these lines. So, across this resistor here, we would have 4 volts. What if they're not of equal value? Well, in this case, we have to use a special formula. Make sure to write this down. The voltage across any resistor in series is equal to the total voltage divided by the total series resistance. And multiplied by the resistor in question. What do we mean by total resistance, and how do we find it? Well, we mean the total amount of resistance being provided by all the resistors in the circuit. In the series circuit, we find this simply by adding the resistor values. If we have a couple of resistors here, say this one is 10 ohms, and this one is also 10 ohms, we'll have a total series resistance, or total, of 20 ohms. If we have more than 2 resistors, the rule still applies. For example, let's get 3 resistors here. And let's say we have a 2 kilo ohm in series with a 5 kilo ohm and an 8 kilo ohm And just for good measure, let's add in a 7.5 kilo ohm resistor. The total resistance of these, or R total, will be 2 kilo ohms plus 5 kilo ohms plus 8 kilo ohms plus 1.5 kilo ohms. That'll come out to 16.5 kilo ohms of total series resistance. Now, let's take a look at a few examples. If we have a 12-volt source and that's in series with a 2 kilo ohm resistor and a 4 kilo ohm resistor, we'll have a total series resistance of 6 kilo ohms. Now, plugging that into our formula, we'll have 12 volts. That would be our source here at the top. And we'll divide that by 6 kilo ohms at the bottom. And say we want to find the resistance across this 2K ohm resistor. We'd have to multiply this 12 volts divided by the 6 kilo ohms by our resistance that we're trying to find, which would be 2 kilo ohms. Now, let's go ahead and plug that into our calculator, and we can see that 12 divided by 6,000 ohms of total series resistance multiplied by 2,000 ohms, which is the resistor we're trying to find the voltage across, we get 4. And that would be 4 volts across the 2 kilo ohm resistor. We could do the same with the 4 kilo ohm resistor, but we know that the total voltage across these two resistors is 12 volts total. So the voltage drop across these combined will have to add up to the source. If we have 4 volts here and 12 volts total, then this voltage must be 8 volts. This is 4 volts. Now, just for fun, we'll plug it into the calculator, and that way we can be sure. We'll have the same 12 volts divided by the 6,000 ohms of total series resistance, and we'll multiply that by the 4,000 ohm or 4 kilo ohm resistor that we're trying to find the voltage across. That comes out to 8, just like we said. Now, let's try a more complicated example. We'll have a voltage source here. We'll say this is 20 volts for this example. And let's put a couple of resistors on here. Excuse my uneven resistors. Let's say we have a 3 kilo ohm resistor here, a 4 kilo ohm resistor here, a 2.5 kilo ohm resistor here, and a 78 ohm resistor here. And we'll look for the voltage across the 4K resistor. First, let's find the total series resistance. So we'll add 3 kilo ohms, 4 kilo ohms, 2.5 kilo ohms, and 78 kilo ohms. We'll go ahead and plug that into our calculator. 3,000 plus 4,000 plus 2,500 plus 78. That comes out to a total series resistance of 9,578 ohms. Now let's plug this into our formula. We would have 20 volts total divided by our 9,578 ohms, and we would multiply that with our 4 kilo ohm resistor that we're trying to find the voltage across. Let's go ahead and plug that into our calculator. We'd have 20 divided by 9,578 multiplied by 4,000. That comes out to 8.352 volts across the 4K resistor. Now, let's try again with the 3K resistor. We'll have the same 20 volts divided by the 9,578 ohms, except instead of 4K, we'll use 3K ohms. Let's plug that into our calculator, and we come out with about 6.264 volts across the 3K. Now, let's do the remaining two just for fun. The 2.5 kilo ohm resistor gives us a value of 5.220 volts. And same as before, if we add all these together and subtract from the voltage source, which is 20, we should get the voltage drop across this 78 ohm resistor. Let's go ahead and add these all up on the calculator. 6.264 plus 8.352 plus 5.220 gives us 19.836. If we take 20 and divide and subtract 19.836, we get about 0.16 volts across this resistor here. We can double check with our formula just to be sure. We'll have 20 divided by 9,578 and multiplied by 78 ohms. Just like before, we got about 0.16 volts. There's a slight difference just due to rounding. That's it for this video. If you have any questions, feel free to drop them in the comments below and I'll try to get to them. Make sure to subscribe and like the video if you found it useful. Also, let me know if you have any video ideas or topics you'd like me to cover in future videos. Stay safe, keep learning, and see you in the next video.